All right, another released FRQ question that has to deal with the accumulation functions in context. So this one is very tricky, especially part C. So hopefully I explain it in a way that you understand it. But again, these take time. You got to go back, rethink it until it clicks. All right, so this example, it says there's no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9 a.m., snow builds up or accumulates on the driveway at a rate modeled by f of t is equal to 7 times t times e to the power cosine t in cubic feet per hour. So this is snow falling. Okay, I'm going to label some stuff. I got to try to get a picture and understand what's going on. So as you're doing these problems, trying to visualize and just figure out what's happening, I think helps a lot, and it just takes practice. So snow is falling at that rate, cool. Cubic feet per hour, I'll keep that in mind later. T isn't measured in hours since midnight, okay. Janet starts removing snow at 6. So I'm thinking, okay, from midnight to 6 a.m., the snow is just coming down, it's building up, no one's touching it. That makes sense, she's probably asleep. Okay, at 6 o'clock, or whenever, she wakes up and she starts removing the snow, so shuffling it off or whatever. The rate, G of t, so this is a rate being removed, is measured in cubic feet per hour, so same. And she's removing the snow from the driveway at time t hours after midnight, and it's modeled here. So from 0 to 6, she's not removing anything, right? The snow is just coming down. Okay, from 6 to 7, she's removing the snow at 125 cubic feet per hour. So she is at 1 hour, right? So she removed exactly 125 cubic feet over that hour. Okay, then she started slowing down, it looks like. For the next 2 hours, she only removed the snow at a rate of 108 cubic feet per hour. So that's important to see what's going on. From 0 to 6 a.m., sorry, midnight to 6, snow's coming down, it's building up. She's not removing it. At 6, for 1 hour, she removes it pretty quickly at this rate. Then from 7 to 9, she's still removing it, but at a slower rate. All right, how many cubic feet of snow have accumulated on the driveway by 6 a.m.? So this is a total amount. I can integrate total amounts, or I can integrate rates to get total amounts. So the accumulating function, that's the way the snow is falling, right? So by 6 a.m., I'm going to find the antiderivative, or the integral, from 0 to 6 of f of t dt. And this is calculator active. So I would just plug this straight into my calculator. I'm not going to try to do that by hand. And I would get 142.275 cubic feet. So remember, that's a total amount, right? Cubic feet. I integrated a rate, which is cubic feet per hour, to just get a total cubic feet. So on her driveway, there's now 142.275 cubic feet of snow. And it's still coming down, right? But we've answered that question. Part B, find the rate of change of the volume of snow on the driveway by 8 a.m. Oh, goodness. All right, so the rate is at a moment, right? Rate of change at a moment. It's not rate of change over an interval. So what's happening to the rate of change at 8? Is the amount of snow growing? Is it coming down faster than she can shovel it off? Or is she shoveling it off faster than it's coming down? So the rate of change, if it's positive, the snow is building up. If it's negative, the snow is being removed. She's faster than how it's coming down. So to find the rate of change, I'm going to compare the two rates. Or what I can do is I can take the rate that the snow is coming down at 8, and I'm going to subtract the rate of change that Janet is removing the snow at 8. And this is calculator active. So I would do 7 times 8, e to the cosine of 8 minus 108, because Janet is removing it at that rate, 108, at 8 o'clock. And I plug this into my calculator, and I get negative 59.58297. I'm going to write out 5 numbers after the decimal spot, so I don't have to worry about rounding. And my answer would be cubic feet per hour. So the rate of change is negative. That means the amount of snow is decreasing from the driveway at that instant. Because this is the instant, at this instant, 8 a.m., the snow is coming down at that rate. It's being removed at that rate, and the only way to get a negative is if it's being removed faster than it's coming down or accumulating. All right. Hopefully this is making a little bit of sense. This is what I'm nervous for. C. Let h of t represent the total amount of snow in cubic feet that Janet has removed from the driveway. All right. Does this have anything to do with the amount of snow coming down? I don't think so. As long as there's not a negative amount of snow being on the driveway, this would be working, right? And it's just going to work out for this one. So if she's removing it at a rate at some point that's faster than it's coming down, at some point she'd be removing like less snow than it was, right? But this is built in. We're just saying there's snow there, and the snow is being removed at that rate. Now, after 9 o'clock, if she gets it all up, and if she keeps shoveling the snow, that number would be less. But we're saying that's the number, so there is 108 cubic feet of snow to be removed every hour. That ramble probably didn't help at all. Anyways, what are we doing? The janitor's being removed from the driveway after midnight. Express h as a piecewise defined function. Okay, so we're trying to find h of t is the total amount of snow. This is rates, right? The rate that she's being removed, we want to find total amounts. And it's going to be different for each little section because she's removing it at different rates for those sections. So for the first one, for t between 0 and 6, not including, I guess we could include 0. Right at 0. This would be, how much has she snow, h of t. And what we're doing here is I'm taking this 0 to t, h of x dx would be h, I guess capital H, no, g, I'm sorry. We're integrating this function, right? We're saying h would be the antiderivative of g because g is the rate, h would give us the total amount. So this would be like h of t minus h of 0. So I'm trying to solve for h of t. So I'm going to think about it like this. How much snow, what's the total amount of snow she's removed at time 0? That's going to be 0, right? Plus the integral from 0 to 6 of g of t dt. Now, really that should probably be some other dummy variable like x or something, but I'm going to keep it t, so I think we're okay. So this would be h of 0, which is 0, plus how much snow did she shovel there? The rate's 0, right? So it should be 0. All right, so from 0 to 6, the total amount of snow is 0. That makes sense because she didn't do anything, right? So for the next interval, 6 to 7, h of t would be equal to h of 6 plus the integral from 6 to t. This is where I probably should put my g of x. Okay, so this one, I see it. This should be t. These should be x's. So no matter what this is, it's just going to be 0, right? Because she's not shoveling any snow. Okay, so back to this. This would be g of x dx. That's equal to h of 6. How much snow has she shoveled at 6? It's still 0, right? Plus the integral from 6 to t of 125 dx. So this would be probably your fundamental theorem of calculus, right? This would be equal to, I'm just going to lose that part. Antiderivative of 125 is 125 x. Let's say 125t. From 6 to t. So what this would tell me is, oh, that's why. Okay, x. I'm so bad at this. X here. It's your dummy variable. I integrate with respect to x. Now plug in your t. So it'd be 125t minus 125 times 6. And I've run out of room. 125 times 6 is 750. So this would be 125t minus 750. So that would be the equation I could use to find the total amount for any time between 6 and 7. So I could plug in 6.5, and I can find out how much total snow she's removed from the driveway. All right, so for t between 7 and 9, h of t would be equal to h of 7, the lower one, plus the integral from 7 to t of g of x. Well, I'm gonna say 108 dx, and that's equal to, well, h of 7. The total amount she's removed would be 125, right? 125. She's removed that at that rate for 1 hour, so it's exactly 125. Could also plug in, what would I plug in there? Probably 7. Plug in 7. 7 times 125 minus 750. And you get 125 that way also. Okay. Plus the integral of 108 would be 108x from 7 to t. So this would equal 125 plus 108t minus 108 times 7 gives me 756. Combine like terms, 125 minus 756, negative 631. So the way I would define h, all nice and clean, h of t is equal to 0 for t between 0 and 6. It would be 125t minus 750 for t between 6 and 7. And then 108t minus 631 for t between 7 and 9. All right, that one might want to go back and look over again in class. I could probably answer your questions better of where I maybe explained something terribly, but there you go. All right, last part. How many cubic feet of snow are on the driveway at 9 a.m.? Okay. This is a total amount, right? I'm not looking for a rate of change. I'm not trying to subtract some rates and see what the difference is. I want to find the total amount of snow on the driveway at 9 a.m. So the snow's coming down and the snow's being removed. So I'm going to take the snow coming down from 0 to 9. This says 9 a.m. F of t dt. So snow is coming down at that rate, F. So if I integrate that rate, I get a total amount that's coming down, accumulating. I'm going to subtract Janet removing the snow from 6 to 7 at this 125 dt rate, and subtract from 7 to 9 at 108 rate. Plug that all into my calculator, I get 26.33461 cubic feet. And that's a total amount, so total cubic feet. All right, if you have any questions next time I see you in class, make sure you ask, and thank you for watching. Bye.